inductive. The first one is not too bad. Like the last 6 times I went to the beach, the traffic was light on Wednesday and heavy on Sunday. My conclusion, you see, my conclusion is that the weekdays have lighter traffic than weekends. That is based on my observation. So I make a general statement based on my observation. And this one is the inductive reasoning. Okay, inductive reasoning. And the other one is similar. A study of 10 people revealed that as they spend more time per week exercising, they experience fewer headaches per month. You conclude that all people will experience fewer headaches with an increase in time spent exercising. So based on just 10 people, to make a conclusion to all people. So that's why these two examples are example of the inductive reasoning. Okay. Then for some examples that help you to find the counter example. For part A here, the sum of 2-digit numbers is a 3-digit number. So this is the statement. Okay. So as you see the sum means plus, right? To add two things together. The sum of the 2-digit number, you can name any 2-digit number, and then the sum based on this statement, the sum come out to be 3-digit number, but there are so many examples that prove it's not true. Okay, for example, any 2-digit number, I make it up. So my first digit is 12, my second digit is 30. When I add these two, or the sum of these two numbers or 2-digit numbers, it came out to be 42. It's still 2-digit number, right? So this is one of the counter example that prove that it's not true. So therefore, it's not true. Okay. Another example, if a number is multiplied by itself, so you can pick any number, then the result is even. The even, like the easy number that you can recall as an even number, like 2, 4, 6, or the number that is divisible by 2, or the multiple of 2. Another way to say that. The counter example, you pick any number, multiply by itself, it comes out to be like, for example, I pick the number 9, I multiply itself, so 3 times 3, I pick number 3, sorry, 3 times 3, I get 9, but number 9 is not even number, it's still an odd number. So this is one of the counter example for this statement or statement B. Okay, so this one, in the case that you have the inductive reasoning, remember inductive, like from small go to the big, like increase inductive. So it's not always true as long as you can find a counter example. So then the conclusion is proved not to be true. Okay, and if we play with the numbers, like the first one here, identify a pattern in given list of numbers, then use this pattern to find the next number. These problems, they are examples of the inductive reasoning. So based on observation. So I put a note here. So based on observation. Okay, like the first part, we have the number 3, 12, 21, 30, 39. Okay, so get out. So for what we have the number 3, the next one is 12, and then the next one is 21, the next one is 30, the next one is 39. It should give us enough pattern. Can you see that? You see, we are working on number 1 right now, part A right now. So we are going to fill in the blanks, the 2 blanks here. What will be the next number after 39? What pattern that you see? Could anyone help me with the pattern that we see? The 3, 12, 21.
48.
48. How would you get 48?
It seems like the pattern is adding 9 to the previous number each time.
Very good. Just based on observation. Thank you,
Mhm.
Jepal. So when we add it by 9, and after the two numbers, we see the same thing happens. Same thing happen until we are so sure that we're going to use the same pattern, right? So we're going to add 9 to 39. So the answer is 48. And then the next number, we would do the same because we carry on the same pattern. So 49 plus 9, or 48 plus 9. So we would get 57, right? Oh, sorry. I have to, whoops. Resume the recording. Sorry. So the first one, can you see the pattern? After we make observations, so we kind of know what's going on for the rest of the numbers that we have to find. So far, so good? Yeah?
Yes.
Okay, good, good. All right, the next one, can you see the first two numbers are the same, 3 and 12. But then third number is 36. The next number is 144. What do you think? The first two kind of do have like multiple options, but the next number kind of narrow it down your choices. What would be the pattern for part B? What do you think? So be 3 and then 12. It could be added by 9 like before. It could be multiplied by 4, right? Okay. And how about 12 to 36? What happens? It's multiplied by 12 to 36. That's multiplied by 3, right? And how about 36 to 144? How to get from 36 to 144? So adding by 9 is out, right, for this one. Think about what would be the possibility to go from 36 to 144. What do you think?
Multiply by 4.
Okay, we can make a guess here. I mean, we can make an observation. All right, thank you, J. Paul. So multiply by 4. And how about the next one? From 144 to 433, 42, sorry. It looks like multiply by 3, right? Can you see? For the adding portion, it would not be the case for part B because we're starting to add by 9 and then the next kind of number is growing and growing, but in different way. But so far, for the first 5 numbers, we see the pattern as multiply by 4 and then by 3, by 4, by 3. And based on this observation, what do you think? What should we get for the next number? How do we get the next number? Hmm? Anyone?
All right. I guess I'll say it. Multiply by 4, so 1,728.
So multiply by 4 to get 1,728. And then how about the next number, dear Paul? What would you do to get the next number?
But multiply by 3.
Multiply by 3 because we see the pattern like, whoops, back and forth, say multiply by 4 and 3 and 4 and 3 and 4 and 3. So multiply 3 to 1728 and we should get the number as 5184. Okay. So another example that we do the inductive reasoning. So based on observation. Okay, how about the last one? Would be the last problem for the day, and then I'll let you guys go. So the next part C, we have 1, 1, 2, 3, 5, 8, 13, 21.
You just add like the 1 and the 1 to equal to 2, and then the 2 and the 1 to equal to 3, and so on across.
So basically you add the previous two numbers to obtain the next one. Is that correct?
Yes.
Okay, thank you, Rola. So let's check to get a number 2, 1 plus 1 to get 2, and 1 plus 2 to get 3, 2 plus 3 to get 5, 3 and 5 to get 8, 5 and 8 to get 13, 8 and 13 to get 21, 13 plus 21, that would give us the next number, which, oh, where did it go? Sorry. Where did it go?
35.
Oh, that would be, try
Oh,
again.
34, I'm sorry.
Yeah, you're fine. So 34, and then, very good. And then add these two numbers again to get the next one. So that would
55.
be 55. Very good. Yep. And if we have to keep going, we use the same pattern. So these are examples of using the inductive reasoning, basically based on observation to obtain the general statement.